Good morning, guys. I hope you're well. Welcome to today's lesson. Today we are looking at the cosine rule. So our last couple of lessons, of course, we've been introducing or going back looking over right angle trigonometry. We then introduced the non-right angle trigonometry. And we looked at the sine rule. We're now looking at the cosine rule. So let's look at a question just to start with, and then we're going to look at the rule and we'll apply it. Let's say, for example, we have 60 degrees. We have x here. We have 15 centimeters and we have, let's say, 18 centimeters. Okay, so our process should always be, is my triangle right angled or not? Now, if it's right angled, then we can use our right angle trig ratios, our SOHCAHTOA, sine, cos, tan. If it's not right angled, okay, the very first thing we look for is the sine rule, as we did last lesson. Now, the sine rule, of course, would be saying, okay, I've got a side and an opposite angle. Yes, that works out. I've got a side and, oh, that doesn't work. I've got a side and that doesn't work. So in order to use a sine rule, you need to have two sides and their opposite angles, and one of them will be unknown. If you don't have that, then the sine rule won't work. We then have to use the cosine rule. So what is the cosine rule? And like we did yesterday, we might use the formal sort of terminologies. I'm not going to go on how the rule eventuates. You can do that later on. I'm more concerned about what the rule looks like. So we spoke about the lettering again of our triangles. The little letters are opposite their angles. In this instance, often what we'll start with, we'll say a squared equals b squared plus c squared. Now, where have you seen that before? Okay, Pythagoras theorem. And yes, of course, it does stem from Pythagoras theorem down the track. You can look at that if you would like to. But this is something that we are wanting to learn. So we've got a squared equals b squared plus c squared minus 2 times those two sides we just used, times the cosine or cos, hence the word cosine rule, of angle A. And you'll notice that we've got angle A, which will be opposite to little a. Now, you'll see when looking at this actual formula to apply to a question, it's really easy to use because there's not really too much you can go wrong because you'll only have one angle given to you. Because if you have more than one, you're probably using the sine rule. So you really can't go too wrong with this in my view. So the other thing people get hung up about is, making sure the A's and B's and the C's are all together. But look at our question. We don't have any A, B's and C's. And so that's really important to make sure that you don't get muddled by that. For example, what if I applied this rule to B side? Okay, find the B. Well, we only have two sides left, right? We had the C and the A. So it'd be A squared plus C squared times 2 times those two sides we just had. And times the cosine, well, what's opposite of little b? Would be capital B. Likewise, what if I said, okay, I want to find the value of C? C squared equals, well, I've only got two sides left, got the A and the B. So A squared plus B squared, okay? And we're going to do 2 times A times B times the cosine of big C. So just know the positions. That's all that really matters here. So let's now apply that rule, okay, to this question. So we're looking for what x is. So we start with x squared equals. Remember, that is the formula. You'll be given that formula, by the way, too. X squared equals. Now I'm going to do my two sides, 15 squared plus 18 squared. It doesn't matter which way they go around. We know that from Pythagoras theorem, or just adding numbers there. It doesn't matter which way they're around. Minus 2 times 15 times 18. Again, doesn't matter which way you times them. It's going to be the same each time. Times cos or cosine of, and see here, we only have one value. We have 60 degrees. There's nothing else you can do. You really can't go too wrong. We now put them to our calculator, so I'm going to do that on the spot. So we've got 15 squared. We're going to add in the 18 squared, making sure. The biggest mistake I see is people times those together and not add them. So just be a little bit careful. That's just more poor use of the actual rule. Because remember, this rule is in your formula booklet that you were given, or your formula sheet for year 9 and 10. Times 15 times 18 times, and the cosine of 60. Okay. And of course, cosine of 60, you might remember that as our exact values. It's actually a half, I believe. So it becomes a nice number. So we get x squared equals 279. Now, the only probably area I see students struggle on, apart from maybe that multiplying instead of the addition for 15 squared plus 18 squared, would be forgetting that we have found x squared. We haven't found x. And that should really jump out at you, because look at your two sides. You've got 15 and 18. There's no way you can have 279 there. It just doesn't work. So we have to make sure we remember to square root our answer. So I'm going to square root. I'm going to press my answer button, and we get 16.7, let's say, to 3 significant figures. I'm going to put a centimeters there. I'm going to put here 3 sig figs because I wasn't told. Remember, of course, when you square root a number, you have a negative and a positive value. It'd be plus and minus 16.7, but because this is a measurement question, we're talking about a distance, we can't have a negative distance. Therefore, there's no real need to say something like x must be greater than 0. You can certainly say that. I mean, technically that's great, but it's certainly not something that you would be expected to have in your answer. They would just be looking for that 16.7. I certainly wouldn't be putting plus and minus, because that wouldn't be a correct answer. Okay, so let's us have a look at example 1, and then we'll come back to looking at example 2 about finding an angle, because it's slightly different with a slightly different rule. Same rule, but just rearranged. So maybe pause this, gents, have a crack at these questions, see what you can come up with, see if you can get the right answer. Off you go. Okay, how did you go? So x squared equals 12 squared plus 10 squared minus 2 times 12 times 10 times the cosine or cos of 50 degrees. I want to see that. Okay, no matter what happens, I must see that line of working. And I write here must see. Okay, because it's showing the marker that you can apply the cosine rule, okay, to this question. Some of the HSC markers and IB as well will simply say 1 mark for an attempt at using the rule. So even if you get a wrong answer, but we need to be able to see it. So if you get the wrong answer and you've only got a bald answer, you get 0 out of 2. Please write down that rule. The next part, if you want to write x equals, by all means, go for it. I'm going to put x squared equals to this instance, but you can just write the answer for the next line, that's fine. So I'm going to type in 12 squared plus 10 squared. A little bit slower on my computer, of course, so I apologize. Minus 2 times 12 times 10 times the cosine or cos of 50 degrees. Now, we couldn't do an exact values question for this one because it's not a 60, 30, 45. Now, we get 89.73, and you'd be surprised how many boys and girls will actually leave that as their answer and not recognize you got 12 and 10. You can't have 89 centimeters there. It just would never work. Therefore, I now need to square root my answer. So I'm going to simply press square root and my answer button, my ANS button, equals, and we get 9.47 centimeters. Now, in this instance, that's incorrect because it wants 2 sig figs. So I'm going to redo that. I didn't read the question. So usually, you know what I'll often do, I'll put 47263 ... and then I'll round it 9.5 centimeters, and that is to 2 sig figs, and that will be perfect. I hope you got that one right. So that's how we find the sites. Now, I'm going to look at and come back up to here this question and look at how we find angles. Angles is slightly different because, you know, when we looked at the sine rule, and I'll just look over the sine rule. The sine rule was nice because you had something like A over sine A equals B over sine B. And if you wanted to find an angle, we could just flip them up. I went through that the other day with that whole idea of 6 over 3 equals 2 over 1. If I flip them, 3 6 still equals a half, it's still correct. So we're able just to flip it upside down to make it easier when one of the angles is what we're looking for to make angle a subject. Then, for example, we times it by A and then do our shift sign. Looking at these questions, not so easy. Now, you could just put the rule and you enter your angle inside here, but it's going to be more challenging. I'm going to look at a question on the run and look at how we might do this. So I'm going to rewrite the rule. A squared equals B squared plus C squared minus 2bc cosine of A. Now, often on your formula sheet, you will actually have the second rule. You will have the rule that's been rearranged. We're going to look at actually how to rearrange it ourselves on the off chance you are not given it. So, in this case, what I'm going to do, because remember, the whole idea is I want to get that equals. I want to make that the subject. So what I'm going to do, I'm actually going to make things a little bit easy for myself. I'm going to get rid of this minus 2bc cos A. I'm going to add it to both sides. Okay, add it to both sides, which means I get 2bc cos A plus A squared equals B squared plus C squared. Okay, so now I'm going to get rid of this plus A squared by subtracting it from both sides. So I'm going to take it across there. So I'm going to get 2bc cosine of A equals B squared plus C squared minus A squared, okay? And remember, I want to get the cos A by itself. So we've got 2 times B times C times cos A. So we could get rid of this thing. What's the opposite of times? Well, it's divide. So divide both sides by 2bc. And I end up getting cos A, so I get rid of a bit of C there. That was a very nice C. Cos A, equals, it's jumping all around today, gents, B squared plus C squared minus A squared all over 2bc. Now that rule will generally be given to you, and that is actually our rule to find our angle A. Remembering, of course, that's what cos A equals. We need A equals, so you'll be doing that shift cos to get rid of the cosine out of the front. Now, looking at this rule, and again, I'll apply it to a triangle, officially, A, B, C, little a, little b, and little c, where this is the angle here that we're trying to find. And have a look at where the letters are. We've got b squared plus c squared, subtract a squared. Now, this is a rule where, it's the same rule, of course, but this is the one where people will make mistakes because they get muddled about which number they subtract, because we have 3 sides here, right? We're adding 2 of them, but then we're minusing 1 of them. What do you notice about the a that we're subtracting? Well, hopefully you can recognize that it's opposite the angle that we're finding. So the 2 that we're adding together, they're the included angle, the included sides. Sorry, they're the ones next to the A, okay, the adjacent sides perhaps. And then the A which we're subtracting is the one that is opposite it. Just like in that very first side where you're doing A squared equals, you have cosine of A, they're opposite angles. And then obviously on the bottom, it's just 2 times B times C. Another mistake, people might muddle it up and might do 2 times C times A, for example. So you just got to be very, very careful. Now, technically speaking, I could change this rule very quickly to saying cos B. How would I do that? Well, I know that the little b, which is opposite, is the one I'm subtracting. So I'm doing A squared plus C squared minus B squared all over 2 times A times C. That's it. Okay, so again, try not to get too muddled around or too hung up on the actual letters, but think about the actual rule in terms of how it works together. So let's look at this question. We're trying to find this theta, this angle inside here. So instead of saying cos A, let's say cos theta. Now, remembering the most important thing for my rule is the 12 is the one that I'm minusing on top on my numerator. So I'm adding the square of 10 and 11, 10 squared plus 11 squared, but I'm subtracting the opposite side all over 2 times the first 2 numbers, okay? Once you do this a few times, it really isn't that hard. Now, to be honest, that's the first step. The second step, and I still see, issues moving on to the second step, but more so we've seen this issue before. So let's quickly do this in our calculator. So I'm going to press my fraction button. I'm going to type in 10 squared plus 11 squared, making sure I enter into my calculator correctly. We're subtracting that 12 squared. And then all over 2 times 10 times 11. Now, again, you can do this in one hit if you would like. Now, we've got 7 over 20. I'm going to just press SD. I'm going to put as a decimal 0.35. Now, The last mistake I kind of see is what we've seen before, that when we do that kind of right-hand working, we think we found the angle. But like I've said before, yes, 0.35 degrees is a possible angle. But is it likely? Absolutely not. It's super, super small. We haven't got rid of this cos. In fact, we haven't even pressed cos. Therefore, it's the cosine rule. It needs to have cos in there somewhere. So we can't divide by cos. So hopefully remember, we need to use the inverse, the cos -1 or shift cos of 0.35. Now, as I said, at the beginning of this question, you could have pressed cos -1 brackets and put that work in your brackets. I do it that way. So now I'm going to press my shift cosine of either answer button or 0.35. I'm going to press equals, and we get theta equals 69.512 ... Now it says to the nearest minute. So to the nearest degree, this would be 70, right? Because it's the nearest whole number. But I'm going to press my bubble button. Remember my bubble button from previous questions looks like this. I'm going to press it, and it says theta equals 69 degrees, 30 minutes, and 45.67 seconds. Remembering that if we're rounding to the nearest minute, that's the one that determines. Now, this is above 30 seconds. Remember, it's a minute, right? So half a minute is 30. Because it's above 30 seconds, theta equals 69 degrees and 31 minutes, and that's my final answer. There's a lot to take in there, gents. I think it's really important that you go through some of the questions and keep on applying the rule, look at the working. Of course, if you have any problems, you can let me know. I might even throw a couple other videos on there later on if you need to see more kind of questions being done. One of the things that people have said to me previously after they look at the sine rule and say, well, sir, do you have any, like, when you get to the obtuse angle, is that an issue? Like, do you have sometimes where it might be an acute and obtuse and they're the same value? And the answer is no. And that's because if you do your shift sine, right, or we had that part where we looked at unit circle, where we know that everything in the first quadrant, all acute angles will give a positive answer. The second quadrant, only sine gives a positive answer. So what happens, right, you might get something that looks like this. And as your second last piece of your working, you might get something that looks like this, a negative answer there. And this is the great thing, because when you look at cosine in the second quadrant, when it's obtuse, we know cos is going to be negative. Therefore, if I do shift cosine of this amount, negative 0.8, what you'll notice that it will automatically tell you that theta is an obtuse angle. Okay, there's no crossing over. There's no potential where that answer could be acute or obtuse. Okay, that's only for the sine rule, because sine is positive in both quadrants. Cos and tan are negative in the second quadrant, so you're going to see it come out earlier on. It just means that if you see that cos theta is a negative value, you know it's going to come out to be an obtuse angle. Okay, because if it's acute, cos must be positive. That's a bit of a side junket, of course. You won't have too many issues with that. Just know that when you're looking for an angle, you have to press shift at some point. Learn your rules. I will, you are given the rules. I accept that, but you should know these rules off by heart. Okay, don't focus on having that rule there that you can look at an examination. Know it up here so you can then apply it really quickly. Any problems, as I said before, gents, drop me a note on Canvas. Apart from that, I hope you're doing really well. We're nearly at the end of trigonometry, believe it or not. Keep working hard and help each other. Have a good day.